Good afternoon. Let's get started. Welcome to the first installment of the spring series of the UT Energy Symposium. Before I introduce our distinguished speaker today, let me make a couple of announcements. For students who are registered for credit in this class, please take a look at the syllabus that is on Canvas, and you are required to post on the online discussion forum within 24 hours. So please, I encourage you to go back and look at the syllabus, and once you're back, make your post by 5 p.m. tomorrow. We have a policy when we reach the question and answers, and actually I think Mark wants to do an interactive session, but we give preference to students. So first we'll try to move around the mic. Before asking your question, wait for the mic to arrive to you, and then we'll give preference, as I said, to students first. Our speaker next week will be Professor Lori Binier, who is an associate professor of environmental economics and policy at Duke University, and she'll talk on comparative analysis of regulations for offshore oil drilling in UK, Norway, and the US. Just for folks who are new here, this is a weekly series. We have this every Thursday, 5:15 to 6:15. So if you just wake up in the morning and want to do something fun, just show up here on Thursday, 5:15. We always have very exciting stuff going on. All right, with that, it's a tremendous pleasure to introduce our speaker today, Professor Mark Ehsani, who is a professor, endowed professor at Texas A&M University. He really leads a very wide variety of research and has done many great things, including leading very top-notch research center there. He's actually a Longhorn. I realized that very recently, and it's such a special treat to have you back here. He got his bachelor's and master's, both from the University of Texas at Austin, and his PhD degree from University of Wisconsin-Madison. He has co-authored or authored 300 journal articles and 12 books. How do you do that, Mark? He will tell us what the secret is for that is. His current research involves power electronics, motor drives, hybrid vehicles, and control systems. He has won numerous awards. He has held editorial positions in many different venues and has started many prestigious publications and journals, which I'm not going to go through. It's a very long list. It's such a pleasure to have you here, Mark. Welcome.
Did I get it on? Okay, great. Well, thank you very much for that generous introduction. It was so enticing. Even I'm wondering now how wonderful this is going to be. It is a truth that I seldom confess that I'm a Longhorn. I've had 2 degrees from here, and I'll tell you another secret. We actually have a weekend home in Austin, so every chance we get, we run away and come to Austin to feel like we're back in the old stomping ground. As you mentioned, if you don't mind, we'll open this to interaction instead of me talking for 40 minutes and you asking questions for 20 minutes. Feel free to interrupt me at any time with comments, well, fewer comments, maybe questions, and even adversarial reactions are welcomed because I anticipate that this may ruffle some partisan feathers. I have no particular agenda. I'm extremely interested and curious about the whole concept of energy. I'm digging into it in all kinds of directions, deep into the physics of it with several PhD students and breadth of it. That's why I'm here. I'm an electrical engineer talking to economists and policymakers as well as fellow engineers and also in other dimensions that has to do with humanitarian things and spiritual things even, not to mention the planetary and environmental things. So I've been doing this for 50 years and I still feel like I'm in a learning mode and embryonic stage. The only thing I can say is maybe I have a little bit more collection of ideas and knowledge than the next guy, but by far not enough compared to the challenge of the field. So here we go. You feel free to interrupt at any time. with your comments. But here's the fundamental premise, of course, that modern life and the significant speed of technological and social development in the West and in the developing world was fueled by energy. We had this fortune of discovering oil and this source of cheap, abundant, easily utilizable energy to compensate for or to overcome wood or even coal, and it's the foundation of modernity. It's been so successful that it's become its own problem now, of course. And here's, I think, in two capsules, the two fundamental problems that makes this seminar and everything that brings us to this room relevant. The demand is increasing and the supply seems to be shrinking. So we're going to some sort of an energy crisis of some kind, perhaps. Sometimes it's here, sometimes it's not. This week we seem to have no energy problem because the price of oil is going down. 2 months ago it seemed to be a big deal. And then the more pressing one that excites a lot of people is this idea of global warming and CO2 emissions. I don't have really any particular view on any of these things. I'm studying them and I'm summing up my studies and I present them. So I'm going to analyze these things one at a time and let's see what we see into it. Although I may not give you any directions or conclusions or even opinions, except for a few very narrow technical opinions, I may help you discard some of your own dearly held misconceptions. And that would be a contribution if I can do that. First, about shortage of energy. The U.S. Geological Survey and other agencies has established pretty well that we have nearly 500 exajoules of recoverable hydrocarbon energy on this planet. Exajoule is 10 to the 18th joules. At current rate of consumption, which by no means is the greatest indicator, but we have 1,000 years worth of hydrocarbon fuels. And these fuels are available very near to the coastlines on the continental shelf all over the world. Almost no region of the world is practically denied this resource. A lot of it is in the form of hydrates, or basically methane ice, which is pressurized and chilled in reasonably deep water, and you strike a match to it and it's like a ball of snow that burns. Very clean. There are many issues about it. Excavating it could release enormous amount of methane into the atmosphere, which is, 1,000 times more potent than CO2 in terms of greenhouse gas, greenhouse production and so on. So, but one component at a time. Right now we're talking about availability of fuel. Do we have enough fuel? Do we have enough hydrocarbon? Is there an energy crisis in the world? And the answer seems to be no, based on factual numbers. Let's look at another angle of it. Let's look at the uranium. Basically a CO2-free fuel. We have nearly 9,000 years of economically recoverable uranium at our disposal. Of course, the price of these, progressively more recoverable uranium may be up 2 times, 3 times, 5 times, 10 times. But when you consider that the price of 1 kilowatt hour of electricity, only 0.2 cents is attributable to the uranium. And even at wholesale, electricity is sold for what? 2, 3, 4, 5 cents per kilowatt hour. It's a minute fraction of the cost, which even if we significantly increase the cost of uranium production, it will not impact the final price to the customer. So that pretty much tells us that even nuclear fuel is in no shortage whatsoever. 9,000 years. Well, that may be a little bit too abstract and big picture. Let me add this thing that we now know. When I put this thing together, it seemed almost shocking even to myself. It's well known that we have a lot of coal, but that's something that almost all of us are convinced that it's so damaging to use in many different ways. Not only CO2, but also mercury and sulfuric acid released to the atmosphere and damage to the environment and so on and so forth. But we have 120 years worth of natural gas with this new technology of fracking. Again, everything comes at a cost, and I'm not promoting any of it, but the question is quantity. It's about, is there a shortage of energy in the world? The unconventional oil, if you add US and Canada, we have 300 years. So not only globally there's no shortage, in North America there's absolutely no shortage. If we are working on a shortage problem, we're working on a 1,000-year problem or a 9,000-year problem. That's beyond the horizon of anything humanity has ever considered seriously. And of course, when I wrote this, I said overtaking. Now we are clearly the world's greatest producer and beginning to become a significant exporter of fossil fuels and oil to the world, notwithstanding the new pipeline that is in debate whether it should be built or not to sell North America, to export North American oil to other countries through the Gulf of Mexico. And of course, this advent of abundant recoverable hydrocarbon oil and gas fuel is because of the shale rock that we have been able to fracture and horizontal drilling, which I'm partially guilty of having developed some of that technology of downhole drilling using electrically driven drill bits and so on and so forth. But we're all guilty of something. You have to get promoted and get tenure and so on. Somebody had a question.
Could you tell me, are these numbers like 9,000 years or numbers such as these, are these based on what is known to exist or does it include probable reserves?
I didn't go that. You're a specialist and I'm not. So this is a very cursory harvest of some of these resources that I've tapped. I have to go back and see exactly. These, I believe, are proven reserves, whatever that means. Again, I would say that with caution because to a petroleum engineer, that is a rich definition. I have no clue what I'm talking about. But no, we know this for fact as far as, in the same sense to a novice, to a layman, as we know for a fact that Saudi Arabia has at least 40 years worth of oil at the current production. So it's that kind of a factual thing. Yes, sir.
Does that include rates of current consumption, or does that include projected rates of China?
Right. Now, I think all these estimates are based on current consumption. We'll talk about that. That's the very crux of today's presentation, actually. That's the pivotal point that I hope to impress upon you, which, again, shows a direction which is not very well appreciated about what to do about energy, environment, humanity, sustainability, and all those things.
Mark,
yes.
Questions you get, could you just summarize very quickly?
Oh, yeah, okay, yeah. Where's the microphone, man? You're supposed to... No, that's okay. I'll repeat it, sure. In fact, it's better because then I can distort it into a favorable question and then answer it. I wish I was that good, but I'm not. So now the issue of renewable energy and environmental friendliness and so on and so forth. It turns out that over the past 25 years or so, the world fossil fuel based energy production has hardly budged, notwithstanding the disproportionate amount of time it gets in the media about this, that, and the other. The fact of the matter is that we're still a fossil-based energy economy and worldwide. In the U.S., only 10% is from renewables, and that sounds very good until you realize we're talking about hydropower. Which is renewable, and in many ways it is very good. I'm not sure if it's good for America, but in many places it may be very good. I'm working with the government of Panama. I think it's much better for them because the alternative is bunker oil. They actually use bunker oil to run diesel engines, to run generators, to supply the country with electricity. That is in so many ways bad that the environmental impact of hydropower there is, in my understanding, much preferable. So I'm working with them about a project called Panama 2040 to to figure out how the government should strategize a complex of energy sources for their future development. When you go to non-hydro, most of it is from corn. We're not in a corn belt, so I guess I'm safe to say corn is not really a very renewable energy source because it's such a sucker for oil in order to produce corn energy. It multiplies the hydrocarbon fuel that is used in its cultivation by only 1/3. So it takes 2/3 energy to get 1 unit of energy out. But things like biomass from garbage, and especially from forest products, that's our renewable picture. Solar and wind is, I can't remember what the number is, but it's very, very small. Does anybody know what that percentage is? I want to say 1% or less than 2% in the U.S. Even though I heard in the State of the Union, the president said that every year this country adds more renewable or wind generation capacity than the rest of the world combined, or something huge like that. I thought I heard that, and I was shocked. So, is that right? He could be that wrong?
He said that he was that wrong.
Oh. Of course, all it takes is a comma or a dot to mislead the public and not be wrong. So it is. I was kind of surprised myself. So I propose to you that shortage of fossil fuel is not a very good thesis to promote. It doesn't motivate anything because it's factually unfounded. The urgency of doing something about the condition of energy complex for humanity and for the U.S. and for the developed world based on fossil fuel shortage is just, even if it impresses certain ignorant people, it's just not, it can be debunked very quickly and based on simple numbers. So then let's look at carbon emissions, greenhouse gases. Let's analyze that and see what kind of misconceptions might be there. And then that goes back to somebody mentioned the idea of whether it's based on current consumption and so on and so forth. Well, it's incontestable that the U.S. is 5% of the world population. Europe is about equivalent in population to the U.S. Together, we are 10% of the world population. Okay, throw in Japan. And that's still about 10% of the world. So the developed world is 10% of humanity. And the developing world, with the significant gap of standard of living in every way, is 90% of the world population. It is this massive percentage of humanity that is growing very fast for a variety of reasons and putting the greatest growth and demand on energy in the history of this planet. That's where the movement is. That's where the demand is. That's where the problem will come from. And that seems to be, they asked Billy the Kid, why do you hit the bank? He said, because that's where the money is. If you want to hit the mother lode, you ought to hit the 90% problem, not the 10% problem. Let's analyze this. On top of that, if we solve the 10% problem, even if we solve it successfully, in some ways it's easy to solve the 10% problem. American problem is surprisingly easy to solve because we are a very dynamic, multifaceted, multi-optioned nation that can shift around for a variety of reasons, just to feel good, or be properly politically motivated, or so on, and so on. But unfortunately, its effect is not even 10%. Its effect may be close to zero. Because, I'll give you an example. We are 5% of the world population. We consume about 25% of the world oil. Whether it's domestic or foreign, it's a recent shift. If we get off of oil completely, we release 25% of the demand. Now, we are pure as the driven snow. We feel good about it. Where do you think this oil is going to go? Is it going to stay in the ground? No. Oil is a fungible commodity. If you don't use it, somebody else will. Why? Because the price is going to keep going down and down and down till the last person that needs to develop and needs energy can afford it. It's even more complicated than that. A supplier like Saudi Arabia will use this elementary lesson that American business taught us a long time ago. Sell them the printer for almost nothing so that they buy a toner from you at $100 year after year. The printer costs $100, the toner costs $120, and whether you use it or not, it'll expire after a year. And you get a warning that this will damage your printer if you keep on using it. I recently finally called their bluff. I said, what do I care? It's a $100 printer. So I kept on using it. So give you another example. Kodak company. Most of you are not old enough to remember the Instamatic camera. It was a revolution. A very good quality camera, very inexpensive. Every high schooler could afford to take thousands of trivial pictures with. And then they kept selling film. Kodak Film Company. And so, so what would Saudi Arabia do? Take a page out of the old book. Saudi Arabia, given that the price of oil is virtually zero, it's worthless, everybody's got green, everybody who can afford it, such as the developed world, Saudi Arabia will go to South America, to Africa, and says, we will build power plants for you for free, as long as you buy oil from us. And we'll be very reasonable. We'll sign 30-year contracts at a fixed price that both of us will benefit from. It's actually a pretty good, equitable thing for Africans and for Saudi Arabians. But it won't do anything for the environment. So getting off the oil for the 5%ers and 10%ers, it's just, to me, it doesn't seem to be, and I'm not alone, actually. I liberally borrow from some of the books I've read in this area. One of them is this guy Mueller. His book is Energy for the Next President. I don't know if you've seen that book. Read that book. Depending on which political angle you're from, it'll either really anger you or it will moderate you, because he's factually pretty good. But of course I read books from every direction, but anyways, here we go. So going back to this idea of current consumption and so on, this is a scenario out of this guy's book. Had we actually stuck with the Copenhagen Treaty that was, being promoted with such fanfare and so on and so forth, the scenario for CO2 emissions by the developed world and by the developing world. And this, I guess, is due to the clauses of the treaty. But notice that the growth is really driven of CO2 emissions by the developing world and not by the developed world. It almost doesn't matter if this curve goes down, collapses, or goes straight. If this is the beginning of the problem, that is definitely, by then, I think I'll be a mature man, but so will you, most of you. It must be a real crisis. Again, where's the problem? Are we solving this problem, or should we attack this problem? That's where the environment will really feel it. If we are concerned about CO2 emissions, use of hydrocarbon fuels, there's no shortage of it, and it will be used regardless of whether we use it or not. We need to be solving the third world problem. We need to be solving the 90% problem. We need to develop technologies that do not hinder, but are green and enhance and facilitate the development of the developing world. It sounds altruistic, it sounds humanistic, it sounds almost spiritual, so be it. The fact of the matter is this is not a new idea. Maybe it was a new idea during the Roman time to go and heal some other race, unknown person's child halfway around the world so that they won't get sick. But now we know for sure that if there's SARS or if there's Ebola or if there's or smallpox or any kind of epidemic anywhere in the world, we will rush in there to heal those people with whatever resources it takes. Why? Because if they get sick, we will get sick. So we understand that in the medical field, that I am my brother's keeper. We are beginning to understand that in the education and knowledge and information field. We really we developed the internet and we gave it to the world freely, and we try to facilitate, we put satellites up there and so on and so forth. We make it as available as possible because we understand that a world that interacts, understands each other, appreciates each other's values is less likely to be hostile to each other. All the hostility we get in the world are from people that we don't know or sympathize with, and much more so on the other side. It is ignorance that breeds this kind of... So we understand these things about health and about education or knowledge, but when you talk about energy, it sounds a little strange. In order to save Mother Earth, I need to make sure that the African villager develops cleanly with the technologies that I develop, or we, educated engineers and businessmen and entrepreneurs and financiers, develop for them. We will go in there and help them accelerate their development the right way. That's the only way to say, if we care about the planet. If it's a common planet and common atmosphere and common environment. To me, now this one I stand by. I can't think beyond this as a good conclusion. You have to solve the 90% problem, and brother, 90% problem is not our problem. And the key word is appropriate technology. And this is where I finally learned to focus my own technical work on. Understand the problem. Understand that clean, renewable, sustainable means different things in different places. One size doesn't fit all. It's not about photovoltaics. It's not about wind energy. It could be about garbage. Bill Gates recently drank some, what he called poop water from Africa because he figured that that's the only way to do it. Take the sewage in a cheap, economical way and convert it into fuel and clean water. I don't know what his business model is, but I'll show you some business models that I do know about. So appropriateness is very important. I have several projects with the government of Saudi Arabia. Believe it or not, Saudi Arabia is interested in renewable energy. It's remarkable. And I have several PhD students from them that are working on this problem with them. Of course, to each his own. I ask myself, is this a fraud? I mean, what is this? Are they trying to use me as some sort of a publicity stunt? Why are they interested in sustainable? Well, the answer is because they want to sell more oil. They don't want to burn it. They want to sell it. They got lots of sun, so why not use their sun for their own consumption and sell the oil where the sun don't shine, type of a thing. Sorry about this Aggie language that kind of creeps out of me. I've been out of civilization for a while. And so also with the government of Israel, a totally different set of solutions, which, by the way, are changing because of the new discovery of natural gas in the Mediterranean. The government of Jordan, and of course, as I mentioned, the government of Panama. Totally different solutions, totally different solutions. We don't have time to go into that, but one of the things I'm beginning to learn is renewable energy, for example, in Saudi Arabia, is such a radical idea, means make water. If we make water for them, economically, they will not burn oil. It's really remarkable. It's a fantastic thing. So there's a whole philosophy about that. We can talk about this offline if you're interested. I call it, you basically have to leverage energy. Renewable energy has got some issues. It's not at our control. It's kind of expensive in many ways in terms of real estate and this, that, the other. And so you want to really use it in a highly leveraged, value-added type of a proposition. You don't want to just use that raw power to turn on light bulbs. It's a little bit problematic to do that for very straightforward technical reasons, which I don't have time to get into. But if you can do some sort of a cumulative value-added product like water, then you can store water, and it's needed at its own pace, but it can be produced in a wild, unpredictable pace. But as long as the two on the average meet, you've got yourself a good solution type thing. Anyway, this idea of appropriate is missed on a lot of people because people like to think simplistically, one size fits all, one ideology, one agenda. So here are a couple of case studies, by no means exhaustive or maybe not even the best, but they're pretty impressive. The government of Bhutan, Bhutan is a little mountainous country in Tibet up there. A few of you may know that. I would love to visit, but I never had the invitation. But they are going to basically completely get off of oil-based transportation. They're going to go all electric and identify very specifically. They're going to use Nissan Leaf electric vehicles to get everybody off that, starting with the government using the official fleets and then dictating by regulation that taxis go to electric vehicle, and eventually the price and the charging station infrastructure will be sufficiently available that the conventional customers will get there. And the reason, again, is very appropriate because they have to import all of their oil, which until recently was a fairly expensive commodity, and it's not a very rich country and resourceful country in terms of natural resources. On the other hand, they have lots of hydropower, untapped and undeveloped. That's number one. So sure, use rain power to propel your vehicles. And the second one, which is a little more subtle, in a very mountainous environment, the worst thing you can do with transportation is to use fuel to go uphill and use your brakes to go downhill. What you want to do is you want to use an adiabatic process. You want to discharge going up and recharge going down, regenerative braking. So you actually you just pay for the parasitic losses in your transportation. It's a very different type of transportation than running on a flat road. So in two fundamental ways, this makes a lot of sense. And here's what they claim. I read this, I can't remember, I think it was in New York Times or someplace. In Wall Street Journal. That they estimate that the daily fuel cost of a taxi driver will go from $13 to 16 cents. That's a coup. It depends on the development of hydropower potential of the country. To me, this is a win-win situation all the way around. We should be rushing in there and facilitating this. We should be giving them capital. We should be giving them technology, and so on and so forth, because they will win, everybody wins. Here's a problem from many directions. In sub-Saharan countries, 1 in 6 people have access to electricity. The rest of the people, basically, their source of illumination is kerosene. Kerosene. I don't know if you've ever touched or smelled or worked with kerosene. I passed my first grade exam under the light of kerosene. I studied for the first grade, and then in the second grade, some people showed up in our house and put wires on the wall, and we had electricity. So in first grade, I remember very well the smell of kerosene and the smoke that used to come out of this glass flue, and the fact that only one room in the house was illuminated with a terrible stink, and the fact that I and the maid every morning had to go with 2 buckets and bring water to the house for cleaning, bathing, cooking, and watering the flowers, and so on and so forth. That's when I decided I'm going to be an energy engineer. and it's been downhill ever since.
If you write that into a statement of purpose, at least we could.
Yeah, that would have, with that I could have got to Harvard. A real tearjerker. No, I would have preferred to come to UT as I did. The amazing thing is that these poor people pay dozens of times more per joule for their energy, which is primarily for illumination, than we in this country do. They pay more for their energy. They're dirt poor, and they live in mud huts and straws, and they pay dozens of times more than we do for energy, which also sickens their children and is polluting this, that, the other. Does this have to do with sustainable energy? Of course. It's about development of the world in the proper way. Leave them to themselves and they'll do what I saw happening in Ecuador. I went to Ecuador with great anticipation when I was invited because I wanted to see a tropical forest. And I was in this city called Guayaquil. And I keep looking and looking, everything looks horrible. You know, these kind of bare rear mountains and hills around it. I said, where are the tropical forests? They used to be here. We burned them all for fuel type thing. So this devastation of the environment, you know, that's kind of a backdoor way of ruining the environment, destroying the oxygen generating green chlorophyll substance. But anyway, so this company in Cambridge, and I visited a few companies like this actually in Cambridge just a few years ago, small companies, very dynamic, called Azori, builds these solar battery charging lighting systems for $50, which of course is beyond the reach of these villagers. And they give it to these villagers for $10, and then they charge them the same price they would pay for their kerosene for the use of this thing until it's paid off. And then they can keep it. So they have the hardware, they have paid for it, no donation, and the sun always shines every morning. And they make a profit and go to the next one. I can't remember when I wrote, 2014. So this is fairly new. They have 21,000 customers, and there are a couple of companies in the US are doing similar things, which have 50,000 customers. And I don't know if any of you read Forbes magazine, but this recent issue, it's recent to me, I kept carrying it around, maybe it's January, December or something, had an article about 30 for 30. It was 30 dynamic entrepreneurs. One of them caught my attention. This African-American young lady under 30 who's come up with this technique of renewable energy for developing world, especially Africa. It's a soccer ball. As the kids kick this ball, it charges itself due to inertial generation, basically. I suppose I didn't tell me what's inside, but for an electrical engineer, it's easy to figure out. So probably some sort of a linear generator that charges a battery. At the end of the day, the kids have exercise, and they take the ball home, and they plug the LED light in there. They got illumination for a very workable period of time, like for the duration of the night, for a couple hours of soccer every day. And she's doing the same thing with Jump Probe. It seems absurd to us, but it's an interesting business model this gal is pursuing. You see, this is not a donation. This is just caring and minding, but first our own principles, if we care about Mother Earth, and then about the problem, which is my brother's problem. It's the 90% problem. I'm going in there and solving it and making money. It seems to me that that's just as motivating and just as beautiful as another social media internet company or whatever, or picture editing company or something, to be bought for $3 billion after a year and a half with, 19 employees or something. All right, I'm not sure how much time we have, but I'm not getting a whole lot of hostility from the crowd, so you're very reserved and diplomatic. I can't even tell if you're liking it or disliking it, but I'll hope for the best and keep on going. Here's the picture, according to some sources at least, of the growth of petroleum consumption, oil consumption in the world up to this year, international. And of course, it's obvious that it's dominated by two colors, orange and blue, commercial and transportation. And since I've been concentrating on transportation technologies and vehicles for the past 25 years or so, I'm particularly interested in the orange one. What a coincidence, 10 minutes, good. So the question is, if you want to suppress this thing, looking at it from another angle now, where would you hit it? Let's hit the orange one. Let's concentrate on the transport, and this goes back to the electric vehicle again. If you want to flatten this or reduce it, come up with alternative ways to carbon-based transportation or hydrocarbon-based transportation. So let's look at that. It turns out that after years and years of study, I have not been able to violate this principle, which began to emerge for me about 15 years ago, that the best fuel for land and air transportation is liquid hydrocarbon fuel. It's unbeatable for a variety of fundamental reasons, not technological. Number one, half of the fuel is free. On the planet Earth, where you're immersed in oxygen, it doesn't make sense to carry your own oxygen, which is the reason the space shuttle had such a huge growth on its belly. That was the fuel and the oxidant. You don't see one of those in a jet, in a 747 jetliner. You don't even know where the fuel is, because it understands that it can suck half of the fuel, which is the oxidant, from its environment, whereas the space shuttle has to carry the oxygen and the hydrogen, or whatever it is, that happen to be hydrogen, but it could be kerosene or whatever, has to carry the whole bundle of fuel with it. It becomes disproportionately heavy and large. Stability, and many other things. And even if you go to gaseous hydrocarbon fuels like natural gas vehicles, not to mention hydrogen vehicles, which are less carbonized or carbon-free, compression of those things requires so much energy. Sometimes 25% of the fuel energy content of the gas tank is in the compression, which is released without use. That means that your theoretical efficiency is 75% before you strike the match. And then, of course, it goes down from there. There are issues about non-liquid hydrocarbon fuels, which happens to be the fuel that everything that has moved on this planet for the past 4 billion years have used, including human beings and earthworms. They all use sugar, liquid hydrocarbon fuel, and respirate. There may be an exception to that with these bacteria they found around the geysers in the bottom of the ocean, but I'm not good with that, so I'll just leave that aside. Here's another depressing but pressing fact. A tank of hydrocarbon fuel plus an internal combustion engine in every way for a vehicle beats electrification, electric vehicle, chemical battery and electric motor, or hydrogen. Notice that I didn't even say was to the left of hydrogen. Where did the hydrogen come from?
I think maybe you need to explain it more, because the well reveals analysis that I've seen
I'll do that.
do not really support that.
Which one? This one?
As far as emissions.
I'll do that in a second. I'll do that momentarily. Okay, let me jump over that because time is short, and I'm just finally getting some response here. Let's look at some densities of energy, density per volume per liter, and density per weight per kilogram of some of the well-known electrical gas tanks. Our run-of-the-mill 200-year-old lead-acid battery and state-of-the-art commercially available lithium-ion batteries, nickel metal hydride is there. So this one is the sweetheart of the industry right now. It's 100 by 100. Let's skip over and look at gasoline right here. The liquid hydrocarbon fuel, 10,000 by 10,000, a factor of 100. So if you want to put a gas tank worth of energy in a battery, the best battery we have, that thing is going to be 100 times bigger and 100 times heavier. You've got a problem.
You have to prorate the fact of different efficiencies.
Yes, I'm glad you mentioned that. I will do that momentarily. That improves it by a factor of 4. So instead of 100, it's 25, right? Unfortunately, that puts it out of the theoretical possibility in the periodic table of elements. So a breakthrough would have to be finding another periodic table of elements, because we understand the electrochemical properties of the most electropositive element in the periodic table and the most electronegative element. And in an ideal electrolyte, if you try to store energy in that, you cannot get close to 25 times. Yeah, let's get that. Yeah, let's do that. What did I say here? Okay, here's another one that keep in mind. Again, don't think of this as a promoter, and I do appreciate what you're saying. Of course, I would rather if you were right than I'm right. but I'm stuck with these facts. The rate of charging our gasoline tank, 5 minutes filling up the tank going 600 miles, is about 4 megawatts. To many of you that makes sense. To those of you who it doesn't, that's about 4,000 homes worth of electricity. Let's skip the prices. That will open up another can of worms. And so the idea of efficiency, as you mentioned, I've got a density of 1% in the gas tank. Electric motor can be about 4 times more efficient. These are rough numbers, but it's okay, than an internal combustion engine. So, okay, it's not 1%, it's 4% of the internal combustion engine plus gas tank. I've got a factor of 25 to overcome. This is the one that I think you are interested in looking at. Let's say that I have an electric power plant that starts with some hydrocarbon fuel. Now, if you say, no, let's start with gas, with solar energy and so on, we can do that. That's not pretty. But let's say, just the way power plants are in this country, they're natural gas. All right, the best, and this is not what we use everywhere, efficiency of modern power plants is about 45%. What is it?
Combined cycle, 60%.
This is combined cycle. Okay. Can we say that we're talking about, right, can we talk about, at least agree that, let's say that we're talking about here and now. Right, here and now. Because there's an issue of transition from here to there, which is another issue to be, there's so many subsidiary issues, but there are so many beautiful solutions. Just like hydrogen is the most abundant element in the universe, except it's over there at, in the stars. So getting from here to there is an issue that, but anyway, terrible rebuttal, but forgive me for that. Anyway, 45%, transmission lines, 93%, these are state-of-the-art stuff. Rechargeable batteries round trip, 80%, state-of-the-art. You're not impressed? That's pretty good. Usually I use 50%. Yeah, okay.
I suggest let's give Mark 5 more minutes.
No, I welcome that. Okay, okay. So let's keep going. Anyway, electric motors 80%. That's also being generous, by the way. But I won't go into that. You multiply those numbers together from fuel to wheel in an electric vehicle. You get a fuel efficiency of 27%. Any old average American car gets roughly 20% fuel efficiency. With advanced technology, hybridization and what have you, you can easily double that, easily. I just came back, in fact last night I was running by remote control some tests on some dynamometers in Ann Arbor, Michigan for an unnamed automotive company that was, with my help, testing their new hybrid electric vehicles. Much better than this, 60 miles per gallon. With hybridization, and I'll talk about that. We don't have time to talk about that. There's a whole new generation of hybridization that is going to have some impact. But anyway, now, fortunately, we're retiring our coal power plants. But if this fuel was starting from coal, then in fact the electric vehicle would be more polluting than the conventional gasoline engines. We can argue about the numbers, but these are today pretty reliable. And I hope I'm wrong, and I need your business card because we need to make music together. So what's the problem? The problem is that energy per pound needs to improve 25 times. The cost of these batteries barely last 100,000 miles. Or about 100,000 miles. That's what the warranty says. That doesn't mean it's going to go another 100,000 miles after the warranty. It's pretty much the life of these batteries. And the batteries practically dominate the cost of an electric vehicle, which are not trivial, by the way. And the weight and volume of these things, and the charging time, which you cannot charge a battery at 4 megawatts for a variety of reasons. Even if your battery could take it, which it cannot, can you imagine having 5 cars in a gas station? That's 20 megawatts. 20 megawatt substation in every gas station? That's not practical. I just gave this talk to my graduate students in my sustainable energy class last night. One of them said, Dr. Ehsani, you missed the boat. You put up solar collectors and charge that would be acres and acres of solar collectors per car in every gas station. That means there should be nothing else on that block but gas stations and their energy. So the problem cannot be solved quite that way. Okay, so we need to move on. So what do you do? Well, I'm not going to embellish anymore. Make electric vehicles. Yes, sir.
Can we build modular batteries so that you can just kind of place them?
Yeah, there's a company in Israel that, again, is getting serious about that. It may work in some places, maybe in small countries or in limited scale. There are issues about that kind of mass transport in and out of a vehicle and the storage of that in the gas station. It's a significant chunk of the car. It's like changing the engine every time you go to the gas station, practically, or bigger. But at least it's on the table, right? There are many issues about that. What are you going to do with the batteries you took off? How are you going to charge those things at a fast enough rate to put it in the next car?
You can charge up the battery so that when you go to a gas station, you just replace the battery. You can build machinery to do the replacement.
Right. No, but then you have to do something with the discharged batteries. If you do the numbers with that's a good statement of the problem. In fact, I'll use that in one of my mini projects in my graduate class. These things can be settled very quickly with one afternoon's worth or one evening's worth of calculations. The infrastructure for that is just not compatible with what we have. And there's an issue. I have 10 principles of how to be successful. One of them is, I don't care how successful your scenario is, show me the path from here to there. That path is obstructed with practicalities of easier detours. But again, don't take this as a rebuttal to what you said. These are the obstacles we do have. Anyway, build a $2,000 car based on the bow and arrow technology of lead-acid batteries and DC motors, which was invented in the 19th century, that can run 40 to 60 miles per charge, which, by the way, is a day's travel in most of the countries, developing countries in the world. Culturally and infrastructure-wise, people just don't travel that far in India and in China and in Africa and what have you. That battery and that DC motor, which is really, really uninteresting and unexciting and cheap and locally manufacturable, can last easily 100,000 miles, which at the rate of 40 miles a day, every day, it's, 10, 20 years worth of service. And now we can talk about renewable or multi-sourced, multi-fueled electrical generation for that, including renewables, wind, solar, and what have you, hydro, whatever. I mentioned this to a startup company that came to me to buy or license my razzle-dazzle switch reluctance motors, state-of-the-art propulsion system for electric and hybrid electric vehicles. I said, don't do that, because they were trying to build cheap, I shouldn't say cheap, reasonably priced vehicles for India. I said, use DC motors. And they left and never came back. They didn't expect a A&M professor to be selling 19th century technology, appropriate technology, terribly important. We shouldn't be so impressed with our technology. We should be impressed with the problem and solving the problem. All right, I'm going to bypass all these because there's an aspect of this, there's supposed to be engineering aspects, but of course I'm not going to torture you with that. I'm going to go to conclusions. Bottom line. If all of U.S. vehicles tomorrow become carbon-free, we have, 200 million vehicles in this country? Over the next 50 years, the impact on the environment is 1/40th of 1 degree Celsius. Should U.S. transportation go carbon-free? Makes no difference whatsoever. So what is this thing about Department of Energy pushing electric vehicles driven by wind? Tesla, $120,000. Every poor man can afford that. Yes, sir. Somebody had a question.
But doesn't the increased use of electric vehicles spur economic experimentation by manufacturers, which would in turn make the process cheaper and more efficient? So it could, God help me, trickle down to other people.
Trickle down? Did you say that? So what you're saying, if you wanted integrated circuits, go to the moon. That's the rich man's way of solving problems. You know, I agree with that, obviously. But the world is too big. Even U.S. resources are not sufficient for this wasteful shotgunning the problem type thing. You need to target the problem areas and solve them appropriately. You know, you cannot say, we want Tesla at $125,000 so that someday the breakthroughs will make Africans be able to afford those cars. It's just, you know, there are easier ways. We can have refined intellect and we can have refined technology solving the problem at its source type of a thing. You know, renewable, affordable energy sources and transportation technologies for the third world, if you will. That's kind of old-fashioned, developing world. There's no second world anymore. So, so I guess my suggestion is, let's not keep on self-congratulating and feeding ourselves even more garbage because of the fertilizer that it produces. Let's really solve the problem at its original source and do it smartly, motivated by market forces, something as inspired and self-interested as the Marshall Plan. We took a devastated Europe and we developed into an economic giant, not because we loved them, but because they were a great market and a great ally. And we made them strong to become even stronger. Somebody had a question.
Who will fund this research that's refined research for
Focus research for these problems? You will. I'm the lone cry in the woods right now. I have not heard anybody say this or even echo this. I'm almost befuddled how revolutionary this sounds. You know, solve the problem where it lies. You know, trickle irrigate your plants in a desert and don't fly over with an artificial rain airplane type thing, you know, fire extinguisher type. It just seems obvious, doesn't it? I mean, anyway, it's not happening. So we need to educate ourselves and buy into these kinds of ideas and do a world Marshall Plan of green energy, human development, so smartly that it's not even altruistic. It's motivated by business motives and lending and the price of money, which is, by the way, cheap. And it will be cheap for a long time, thanks to people of my generation, which won't spend so much. So, sorry.
We are out of time.
Obviously. So I'll just page through these things in a silent way that, sorry. Hybrids are the way of the future for this country. In this country, and the 10% should improve efficiencies with better products. We should inspire the rest of the world with our efficiency, even though mathematically we are irrelevant as far as the environment is concerned because of fungibility of fuel. But we can inspire the world by becoming more efficient and then going over there, instead of building Tesla companies, going in there and building lead-acid DC motor $2,000 cars for India and making it look sexy for them using Madison Avenue techniques. That sells garbage to us at high prices and we suck it up like it's cat's meow. We can make automobiles so much more efficient with hybridization, light materials, synthetics, collision avoidance. Intelligent collision avoidance is a word I actually coined 25 years ago. And now it's on every car. It's legally required, actually. I'm gratified, even though I didn't get the Nobel Prize for it. The only reason this is not happening is because if everybody drives a lightweight vehicle with composites, and one person cheats and drives the type of cars I drive, big SUVs, then I'm safer than everybody else. And so everybody else will cheat again. This is called Commons paradox, or paradox of commons, which is another discussion. So that's why we need a government type of oversight to raise the standards so that nobody can violate the common good without anybody sacrificing anything, but it just keeps the playing field level. Anyway, so I could talk to you about predictions of the future that are often wrong. Who was it, Maharaji, that said those who predict the future must do it very frequently to be right? Thank you very much.
We take just a couple of questions. Students first.
Thank you for the talk. Just as long as we're talking about the 90%, from an ideological perspective, we have people having such basic arguments as, Jeff Sachs saying, let's throw all the money we can to the developing world, and others saying, let's not throw any money, let them do whatever they want, they'll develop better that way. Even if you remove money out of the picture, we have when we talk about technology, we have corporations waging war on developing countries for trying to develop their own technology. If we remove that, we have, small entrepreneurs trying to make profit selling their product to rural poor, whereas the urban rich are getting subsidized power. So when we're having, I feel like we're fighting the wrong war.
Yeah.
There's a huge lack of political will, even in the developing world. There's huge inconsistencies with skill and educational capacity to even hold on to these technologies. We have all the money, we have all the technology, but so I just feel like we're fighting the wrong war.
Pretty brilliant. You ought to be studying at A&M. You're a pretty bright student. Yeah, I did get 2 degrees here, absolutely, and then I worked for several years here as a research engineer. No, you're right on target. But the thing is, money and the dynamics of money and the capital markets in this country are fantastic. The aggressiveness and the entrepreneurship of our business people and young people is fantastic. It's the mindset. We don't even realize that there's a whole different way to be profitable and also be satisfied with the outcome. This kind of adversarial, extraneous or hidden cost type of business that we do, you pollute the environment, there's no cost associated, it's not even quantified in terms of the same dollars that you do your business in, pollution in the air and what have you. That business model is taught that way in the business school. That's the way Harvard teaches it, or what is it, McComb's School of Business, some of these prestigious schools. So the mindset needs to change. At no sacrifice, just solve the right problem, and understand the problem in a technical, scientific, unbiased way, type of thing. That's, in some ways, very simple, and in some ways it has to start with educated, especially young people. Sorry, somebody else said it.
Yes, I had a comment on electrification of vehicles. I think that your presentation lacks looking at various other benefits that we didn't talk about, such as, you no longer need oil changes. You look at the entire footprint of the electric vehicle, you don't need all these parts and all these moving parts and exhaust systems and muffler shops and oil change locations. You're looking at a much simpler infrastructure, and with the advances in batteries, so you can almost look at it like the microchip. It's advancing so fast. I think that without any subsidies or anything, the electric car is going to be the paradigm shift, and I think that's already happening with GM announcing a 200-mile range electric car, the Bolt. You have just so many efficiencies, and you have no air pollution. So you said if we changed all the cars to zero carbon, it would make a difference. I think it'd make look at LA. The smog is unbearable. It's a huge health problem. So I think transportation being electrified is the way to go.
Do you drive an electric vehicle, sir?
I do.
You do? Gee, you just shut down my big... But I think you're completely wrong, I'm afraid, on every account that you mentioned. And the only way to figure that out is to do some calculations. Electric vehicles were introduced in the early 1900s. And not only has what you said not proven to be true throughout the history, but it's not technology dependent. The fundamental laws of nature are not behind it. That's the problem. And it's not pollution free. Where do you think electricity comes from?
Signed up for green choice, supposed to come from wind and solar.
Do you know that wind and solar also take oil to build? And it's not clear that they actually pay back the energy it took to build them? Did you know that it takes oil to have sun? I actually have a PhD student doing this groundbreaking calculation for me. Does a wind turbine pay back the energy it took to build it? And then when it does, what have we accomplished? Nothing. So will it then, well, I can't go into details because then the poor kid won't get his PhD, but yeah, every one of these things are problems to be analyzed. I like the way you listed the titles, but then you have to do the calculation. You have to write the article and do the thesis. It's not as rosy as you think it is. It's not a principle-driven campaign. It's a physics and technology and numbers-driven campaign, and it's not panning out that way. I wish I was wrong, and I wish you were right. But it doesn't matter. Let's solve the problem where it counts, such as in Africa and in India. That problem is solvable because Beijing and some of the cities I've been in India are really suffering, absolutely. Forget about our cities because we have so much money to take care of things quickly if we wanted to. It's about the bigger problems in bigger cities with much fewer resources to take care of.
Well, I worry about local pollution.
Yeah.
We all had electric cars, so we breathe better air right here now.
Well, I'm worried about the 90% not being able to breathe well as well.
We are way over time, but we cannot end this talk without asking you even harder questions because you pushed the IC engine EV discussion a little too far. So let's have Dave comment. Can you use the microphone?
Thank you for coming all the way, especially in this weather. Thank you for coming all this way, and it's an engaging conversation to have. When we talk about data, I'll send you a link. Daimler, a fairly substantial automotive company, they have a well-to-wheel analysis tool. There's actually a professor at Stuttgart that I've engaged with, and he can send an advanced one. As far as the data shows that they do save, and their life cycle analysis even going beyond well-to-wheels. So I'm not sure where you're coming up with the ideas that the data doesn't support lower emissions overall. On top of that, if you really want to go to the next level, this tool's easier. You can use Argonne Labs' GREET tool, and so experts like Michael Wang and others, this really isn't too controversial as far as well-to-wheels being superior. And so there's a lot more that I think goes into more depth than your sort of back-of-the-envelope calculations that have shown it to be positive.
It's back of the envelope in a 40-minute talk, you understand, with many other problems.
I'm sorry, the data from other sources just doesn't back up what you're saying.
Would you kindly answer the following question then?
You'll have to prove with tools that have more credibility than people that have been doing this for many years, perhaps even staffs and PhDs, more than you and yours, that refute this data that's kind of well known.
If it's so good, why isn't it penetrating? Sorry, but I hate to be so impertinent as to throw the reality at you.
No, and by the way, I've enjoyed burning hydrocarbons. I have an artificial knee because I used to race motorcycles.
Let's not confess anything because I could really scoop you on that one.
Yeah, I bet you might have. So I've enjoyed burning hydrocarbons all my life, and so I appreciate the value. And as a matter of fact, there was an interesting, somewhat controversial paper on how fossil fuels and hydrocarbons have really elevated the human race over the past few centuries. And there's no question. It's a matter of what's going forward. And so the technology
have been progressing. And I think the most essential one, there was an interesting report from Ricardo on the trajectory of costs. You know, we see with the advanced DI, multiple valve, variable valve timing, turbo, downsized, you know, very sophisticated engines, 9, 10-speed transmissions. The trajectory of those costs is going up to meet 2025 CAFE regulations, perhaps up to $3,000 more. It's on an upward trajectory. That's a fact, okay? So the next thing is looking at the technology-based trajectory of about 5 to 8% compound decline rate of batteries. Power electronics, which I think you have a lot of familiarity with, they're getting improved densities and costs over time too. So there's actually a decreasing cost curve over time for electrified powertrains. And on top of that, you could say, well, you could lightweight, look at the new F-150, but that's a common technology that will help both.
Yeah.
Right? So I see these trajectories that by 2025, the price premium may be so modest and the other superior attributes like performance and maintenance and other things, it's good enough to get close enough.
If we do all that, what will we have accomplished?
Well, we have a trickle down. I'm not going to use the same term, but the fact that the
Why would we want to trickle down when we can get down and solve the problem?
I love the idea of specific market.
Why should we feed the horses so that the sparrows can eat?
Mark, Dave, can I ask,
Sorry, I'm being unfair to you
can I
because
ask Mark to maybe just quickly respond to the IC engine cost trajectory versus the batteries and power electronics cost?
very quickly. Again, I've been accused of back of the envelope, and that's all I can offer right now. You cannot build a car at any cost with electricity, with battery and electric motor, which is as good as a run-of-the-mill conventional car in terms of a customer expectation. Believe me, you can't get the acceleration, you can't get the range, you can't get the charging time. Absolutely, this is just not physically possible.
All right, we are way over time. Let's thank our speaker again. Thank you so much.
Thank you. That was good. That was a good.